This lecture is on multiplication of polynomials. Now, before we start with that, let's recall something that we have seen earlier. Supposedly, you're asked to multiply 2x cubed with, say, 5x to the fourth power. What you see here is a product of two monomials, as in single terms. So when that happens, all you have to do is take the number to multiply with the number. So 2 times 5 makes it 10. And when you look at x cubed and x to the power 4, that's when you apply the rule of exponents that says that if there's two bases and two exponents, you add the exponents. So it becomes x to the power of 7. So this is where you multiply the numbers, but you combine the variables using the rule of exponents. So you do that for single, okay? So you do that for monomials. So the big question is, what if you don't have monomials and instead you have, say, 2 plus x cubed, and let's say a 5 minus x to the power 4. So what you see here is actually two terms in each, okay, and you're asked to multiply them. So when that happens, you're going to have to use FOIL. FOIL is a mnemonic, which is a word that helps us remember the process. F stands for first, meaning you take that 2 and multiply with the 5. So that's first. So 2 times 5 makes it 10. O stands for outer, which means you take the 2 and you multiply to the negative x to the power 4. So 2 multiplied, so in all this is multiplication. So 2 times negative x to the 4 makes it negative 2x to the fourth power. I stands for inner, which means you take the inside terms. So x cubed multiplied by 5 makes it 5x cubed. And finally, L stands for last, which means you take the x cubed, multiply to negative x to the fourth power. So again, you see two bases and two exponents, so you're going to have to keep the base but add the exponents. So the rule I'm applying here is when you have x to the m multiplied to x to the n is where you add the exponents, okay? So that was product rule in rule of exponents. So that will give me negative x to the power of 7. Now at this point you now have 1, 2, 3, 4 terms, and you have to look to see if you can simplify them any further, meaning you have to look for like terms. And if there isn't any like terms, you stop. Okay, so like terms, so look for like terms. And remember what like terms mean. They must have the same variables raised to the same exponents, exactly the same exponents. Okay, so since they're all different, you stop, and so this is the product. So let's look at more examples. Let's try something with fraction. For example, half x squared multiplied to 8x squared minus 6x plus 1. So in this case, I don't use FOIL because there's only one term here, and all I have to do is to distribute the term into the parentheses. So what I'm doing here is I'm distributing. So when I distribute, what I do is I'm multiplying the numbers with the numbers, and for the variables, I will combine their exponents by adding. So half times 8 makes it a 4, so you can think like that. What's half times 8 over 1? So that reduces to become 4. So it's 4, and x squared with x squared makes it x to the power of 4, minus half times negative 6 makes it negative 3, so that's negative 3, and x squared with x makes it x cubed. And finally, 1 half x squared times 1 makes it 1 half x squared. So again, you're looking for like terms, and if there isn't any, you stop. So let's try another example, 2x minus 3y with, let's say, 5x plus 4y. So this time I'm going to use FOILing. So first with first, 2 times 5 makes it 10, and x with x makes it x squared. 2x times 4y makes it 8xy. Negative 3 multiplied, so remember it's multiplication, to negative 3y multiplied to positive 5x makes it negative 15xy. And finally, negative 3y with positive 4y makes it negative 12y squared. So at this point, you're going to have to look for like terms. So you notice that you're going to have to combine these. So what you get is 10x squared. 8 with minus 15 makes it negative 7. And they are xy terms. And you're done. Okay, so when we combine like terms, what we do is when we combine like terms, remember what you have to do. You have to add or subtract the coefficients, which in this case 8 and 15 makes it negative 7, but you have to keep the variables. Okay, let's try something that has fractions involved. For example, 3x minus 1/4 multiplied to 5x plus 1/5, for example. Okay, so let's try that. 3x multiplied by 5x makes it 15x squared. 3x times 1/5. So think like this, 3x over 1 times 1/5. Nothing to cancel. So what I have is 3/5 x. Next, I'm using the 1/4, negative 1/4 multiplied to 5x. So you could put 5x over 1, so you can see better that it's negative 5 over 4x. And finally, negative 1/4 multiplied to 1/5. In multiplication, I don't need the same denominator, so I'm going to combine these and call it negative 1 over 20. So this was 3/5 x, and this was negative 5 over 4x. Okay, so at this point, I will notice that these two are like terms. And when they're like terms, I have to combine them. So that means I have to now consider what's positive 3/5 with negative 5/4. Now these two have different denominators, so I have to make the denominators the same. And that means I have to multiply the top fraction by 4 and the bottom fraction by 5, making this positive 12 over 20 and this negative 25 over 20. So now that they both have the same denominator, I can combine them, and I keep the sign of the bigger, numerically bigger fraction, and 25 minus 12 makes it negative 13 over 20. Okay, so what I have as my final answer is 15x squared minus 13 over 20x and minus 1 over 20. That's my final answer. Sometimes we write it using the square. So, for example, if we were to ask you what's 7xy minus 2z all squared. So make sure you understand that's just a compact way of saying 7xy minus 2z multiplied by 7xy minus 2z. So you can think like that, and that's when you FOIL. So 7xy with 7xy makes it, remember it's multiplication, you're not adding, you're multiplying. So it's 49 x squared y squared. 7xy with 2z is negative 14 xyz. Negative 2z multiplied to 7xy is again negative 14 xyz. Notice I wrote beneath it, so I'm going to combine like terms easier this way. And finally, negative 2z with negative 2z makes it positive 4z squared. So when I add, I'm going to add downwards. So that gives me 49x squared y squared minus 28xyz plus 4z squared. And that's my answer. This trick that you see here is especially useful if, let's say, there is more terms in the polynomial that you're multiplying. For example, if we want to multiply 4x squared minus 2x plus 3 to 5x squared minus 4x minus 7. So if you write it in a long line, it can get quite challenging. So what I'm going to do is I'm going to line them up like the way I showed you in example 4. So I'm going to multiply 4x squared with 5x squared. This is multiplication, keep in mind. 4 times 5 is 20, and x squared with x squared, 2 and 2 makes it 4x's in total. 4x squared multiplied to negative 4x, numbers with numbers, makes it negative 16, so 4 times 4 is 16. X squared with one more becomes x cubed. 4x squared with negative 7 makes it negative 28x squared. Okay, so now I'm done with distributing into the second parentheses. I'm starting with the next term, negative 2x multiplied to 5x squared. So that makes it negative 10x cubed. And notice I'm writing under the x cubed family. Negative 2x with negative 4x makes it positive 8x squared. And negative 2x with negative 7 makes it positive 14x. So I have one more term in the first parentheses, so the story repeats. I'm going to multiply 3 with 5x squared, making it 15x squared. 3 with negative 4x makes it negative 12x, and 3 with negative 7 makes it negative 21. So notice I lined them up. So now if I combine like terms, it's a bit easier to see because now I can see x4 is alone. And x cubed, there's 2 of them. So negative 16 with negative 10, they have the same sign. So I'm going to add them, but keep the sign. So it's 26x cubed. Okay, negative 28 with positive 8 makes it negative 20. And negative 20 with 5 makes it negative 5x squared. Positive 15 with minus positive 14 with negative 12 makes it 2. Positive 2 and minus 21. And that's it.